Welcome to Relief Tutors. In the last lecture, we have discussed about difference between compound and mixture, and today's topic is now about types of mixtures. See, already we know that in mixture the substances just got mixed up physically. There is no chemical reaction occurring between them. None of the component of mixture is losing their chemical properties. It remains as it is. They can be separated easily also. All the things we understood in the previous lecture. Now, types of mixture is now on the basis of how the substances got mixed up. Whether they got mixed up evenly, thoroughly, or they are not mixed up, means they are mixed up unevenly, having the different densities everywhere. So, based on that, we have two types of mixtures. First is homogeneous mixture, and another is heterogeneous mixture. Homogeneous mixture. This is the mixture in which components mix with each other evenly. Evenly means what? That both the components mixes thoroughly and both the components present everywhere in the mixture. For example, here is the glass of water, and in that we are adding common salt. We know that salt is a soluble substance in water. We stir it very well. So after some time, what we will see? We will see that the salt dissolved. So where these salt particles goes? The salt particles present everywhere in the solution. So from wherever, for example, you are taking one of the sample of solution from the top of the solution, from the middle part of the solution, from the bottom part of the solution. If you take, for example, 5 ml each, 3 different samples you are studying, and you want to find out whether the salt molecules present equally everywhere or not. Obviously, water is present everywhere. We just want to understand salt molecules are distributed equally or not, evenly or not, thoroughly or not. So here you will, when you study this type of samples, you will find out that the salt molecules are present everywhere, are present evenly. So in the scientific language, we can say the density of each component is same everywhere, is uniform everywhere. So this is the solution in which two components, two or more, whatever, but here the two components mixes evenly. So the density of the solution is same everywhere. Wherever you see, the salt will be in equal amount in water. This type of mixture is called as homogeneous mixture. Okay, so this is an example of homogeneous mixture. Same way, if you dissolve sugar in that water, so you will see that those particles again will be distributed equally. So this is called as homogeneous mixture. What about the heterogeneous mixture? Heterogeneous mixture means a mixture in which components are not mixed with each other evenly. Here the two components, okay, mixture is obtained. but the two components are not present everywhere. Let us say sand is added in water. So this is a glass of water and we have added sand in that. So we know that sand is insoluble in nature. So it will be deposited at the bottom. Okay. In sand, for example, some particles of clay also present. So the clay particles are distributed maybe slightly above the sand particles. So now look at this mixture having 2 or 3 components. Water is present, mostly the water present over the sand particles. So if you study the 3 different samples from the different locations, if you take one of the sample from top, one of the sample from middle part and one of the sample from bottom part, so here on the top sample you will not find any other particle except water. So here you can say that it is not even a mixture, because this sample is only made up of one type of substance, that is water. No other substance is seen in this sample. Here what we can say, here some particles of clay may be observed during the observation, and here you will find most of the particles of sand there. So here and here the composition of mixture is different. In the homogeneous mixture, the composition of mixture, the structure of mixture is same everywhere. Okay, so here this type of mixture is called as heterogeneous mixture, in which the molecules of one of the component is not present everywhere, means they are not distributed equally, they are not distributed evenly, not thoroughly. Based on this, one more topic. So this is the type of mixtures. Now based on the types of mixtures, we have one word called solution. Or if you think about, mixtures also can be classified in 3 different ways. Solution, which is sometimes called as true solution. Another one is suspension. Suspension solution. And one more is colloidal solution. But today let us see only about the solution, the true solution. First of all, what do you mean by solution? When one of the substance has the ability to dissolve another substance. Let us say here is again water, the old example, and we are dissolving water in the salt in that. So water which is present in the greater amount is called as solvent, and salt which is in the lesser amount is called as solute. So what do you mean by solvent? A substance which has a tendency to dissolve the other substance. Solvent means, again, if you want to note, make it. Solvent means a substance normally present in the higher amount, which has a tendency, which has the ability to dissolve other substance in it. So that is called a solvent. Solute means a substance normally present in the mixture in the lesser amount, which is dissolved in solvent, is called as solute. So here water is a solvent, salt is a solute, and the newly formed mixture is called as solution. So this is the solution. Solution of what? Solution of water and salt. But normally, listen to me, it's very important. It is named as solution of salt in water. You can add in water behind, but normally the solution is named after the name of solute, which is dissolved in solvent. So this is called a solution of salt in water. If you dissolve sugar in that, that will be called as solution of sugar in water. Remember, true solution means solution is the solution in which the solute particles are distributed equally in solvent. So solution means solution is a mixture in which solute is distributed equally in solution. Solute is distributed equally. We have seen that salt is dissolved in water, so salt particles are distributed equally everywhere. Okay, so that is called as true solution, means a solution. So I think this is the same as homogeneous mixture. So we can say that solution is homogeneous mixture. Step by step, we are trying to understand the properties of solution. First one, solution is one type of homogeneous mixture. The solute particles, means here the salt particles. If you do this activity at your home, you just dissolve some spoonful of salt in water, and once the salt is dissolved, can you see those particles of salt once it gets dissolved? I think these salt particles will not be visible with the naked eye, because these particles are dissolved and converted into its molecular form. They get dissolved means what? Dissolved means each and every molecule gets separated and they present everywhere. If you microscopically observe, let us say these are the water molecules. So the salt molecules, what you have added the powder of salt, which is visible to you. But once you stir it very well, the powder converted into, means molecule, each and every molecule of NaCl, each and every NaCl get separated, and those NaCl molecules take the space between the water molecules everywhere, means uniformly. Okay, so these particles of solute are quite small and they cannot be seen with the naked eye. So those particles, size of solute particle are nearly 10 raised to minus 9 meter, means it is nearly 1 nanometer. Is nearly the size of 10 raised to minus 9 meter, means it is 1 nanometer, and not visible with the naked eye. And the name of means what, these solute particles are famous as molecules. We can say that now the salt particles are converted into its molecules. Because this particle size is very small, if you think about this again, these are the salt molecules, which is extremely small, 10 raised to minus 9 meter size, not visible, because they are too small. So if you incident the beam of light, so this beam of light means light rays will not get affected by these molecules. So when the light goes, it only refracts because of the water molecules, but the salt particles are too small so that they cannot disturb light. Disturbance occurring in light is called as scattering. light rays is not going to be scattered, and once the light ray, see, if you imagine that light ray is going in one of the direction, salt molecule is there in between, but because it is extremely small, the light ray passes as if nobody is present, as if no particle is present in its path. So such type of particles, that is why not visible to us, because light do not fall on that. And if the light does not fall on the particles, we cannot observe it by the naked eyes. So two things to remember: why we cannot see, why they are not visible, because these particles are too small, so the light ray is not going to reflect, not going to get disturbed, not going to be scattered. The proper word to be used is what? Scatter, disturbed. So light ray, beam of light is not going to be scattered with the help of this particle. So what we can write? Beam of light is not scattered. It's important thing to remember that beam of light is not going to be scattered with the help of these particles. One more thing, if you see, consider again, this is water, again we are dissolving salt in that. Once the salt gets dissolved, okay, salt is dissolved. Now you just keep this solution as it is. Do not disturb the solution. Just keep this on the table, flat floor, and do not disturb it. So what? So what do you think? Are these molecules gradually coming down and settled at the bottom due to gravity effect? Is it going to happen? Number of times we have seen this in our regular life, that some sand particles, some clay particles is gradually settled down at the bottom. Okay, but here these molecules are converted into, in its molecular size, into its 10 raised to minus 9 meter size, and also these salt molecules are actually surrounded by water molecules. So water molecule has a force of attraction with the salt molecules. So these water molecules, which is present around the salt molecules, are not allowing salt molecules to go down. So these molecules of salt, means solute, are not going to settle at the bottom. So two things. For example, you are stirring this. So the solution is in motion. Solution is in motion. So during the motion, you can consider the particles are moving here and there. But if it is steady, not disturbing, then also the particles are stable. Such type of solution in which there will be no change, whether the solution is in motion or steady, there will be no change in its composition. Such type of solutions are called as stable solution. So here we can say solution is stable. So what do you mean by stable? Stable means composition of solution remains same, no matter whether the solution is moving or stationary, doesn't matter. So solution is stable because the particles are not settling itself at the bottom. One more thing, can you separate these salt molecules from the water molecule by filtration? Obviously not, because these particles are too small. So this solution cannot be, we can say, solution can't get separated by filtration. So these are some important properties of true solution, in which the solute particle is distributed equally in the solution. The particle size is 10 raised to minus 9 meter. They are called as molecule. They are not visible with the naked eye. The beam of light is not going to be scattered. Solution is stable, means its composition remains constant, and these particles cannot get separated by filtration process. Let's have some examples. So I think the examples are quite easy to understand. The first one already we are discussing, that the salt is dissolved in water, sugar dissolved in water, you can say, Many such examples are there. The one very important example is what? Tincture of iodine. First example, what you can say? Sugar plus water. Second example, salt plus water. Third example, tincture of iodine. Tincture of iodine means it is actually iodine plus alcohol. Iodine plus alcohol. This mixture is called as tincture of iodine. Iodine is solute and alcohol is solvent. So this mixture is again a homogeneous mixture, means a solution. And I think this tincture of iodine is normally used in the dressing of the wound. I think we have seen this, Dettol, Savlon. This type of solutions are available in market. So iodine plus alcohol is called as tincture of iodine. This mixture is a solution. The drinks, aerated drinks. Thumbs up, Pepsi, Coca-Cola, in which one of the carbon dioxide gas is mixed with the liquid. That particular liquid is mixed with the carbon dioxide gas. So this is again the carbon dioxide solute present in the liquid everywhere uniformly. Okay, these are some examples. One more example we can discuss, scientific example, that alloy formation. Alloys are nothing but the homogeneous mixture, means the solution of metal plus metal, means two or more metals, or it should be the mixture of metal or metal and non-metal. So the homogeneous mixture of metal to metal or homogeneous mixture of metal and non-metal is called as alloys. Stainless steel, which we use, the utensils at our home are made up of stainless steel. Stainless steel is one type of alloy. The bronze medal, the bronze is also one type of alloy. The brass substances, means some handles of cupboards and etc. They are made up of brass maybe. So brass is also one type of alloy. So this is all about the solution. In the next lecture, we are going to understand about the other two types of mixtures based on the solution, colloidal solution and suspension solution. But before going towards that colloidal or suspension, in the next lecture, we will understand two more terms regarding solution: saturated solution, unsaturated solution, and concentration of solution. Till then, best of luck.